All right. Hello, algebra. Hey, guess what? It's the last week. Oh my God. Can you even believe it? So exciting. Okay. So last week we did exponential functions. And this week we're going to look at our last type of function for the year, and that is square root functions. So square root functions are easy to tell. So remember, linear functions, you have just y equals x, right? Where x is a base with an exponent of 1. Quadratic functions, you have y equals x squared. So again, x is a base and it's raised to the second power. Exponential functions that we did last week, we have y equals a times b to the x. So remember, we knew that because x was in the exponent, hence the name exponential functions. And then now, square roots are easy to tell because x is under a square root sign. This is called, so sometimes you'll hear me say square root, sometimes you'll just hear me say root, and sometimes you'll hear me say radical. So a radical is essentially like this symbol because the way it is right now, it's just a square root, but it can be a cubed root or a fourth root or a fifth root or a sixth root. And so when we're just talking about in general terms, we say radical. Okay, so let's take a look at this. So this says the function 8 rad x, or 8 times the square root of x, whatever you want to say, gives a speed in feet per second of an object in free fall. Fill in the table to find out where the object would be at the given x values and graph the function. So if you have a calculator, this is really easy to just throw in your calculator and do. If you don't have a calculator, then you have to be a little bit kind of creative with this. So because when you're taking the square root of x, the only times that it's really like an easy number to deal with are your perfect squares, right? And we'll go through a list of those again tomorrow. But those are like square root of 0, square root of 1, square root of 4, 9, 16, 25, 36, and so on and so on, right? So those are the ones, like your perfect squares are the ones where if you take the square root of it, you end up with a whole number. So your only perfect squares you have in this table for x are 0 and 25. So you would just do 8 times the square root of 0. Square root of 0, of course, is 0. Times 8 is 0. 25, so 8 times the square root of 25. Square root of 25, remember, is 5. So this would be 8 times 5, which would give you 40. Now, the problem here is if you just graph 0, 0, and 25, 40, could make you think it's just a straight line between these, and that's not the case at all. So that's why you might need your calculator for this. So let's just go to our calculator, get out of the glare, and hit y equals, clear out anything that's already in there. And we're going to put this function in. So 8 times the square root of x. Remember, you hit second x squared. Sorry, you can see that. Second x squared to get that radical. And put x. Now, I want these particular values in a table. If I go to a table, I can do one of two things. I can just look for 1 and 5 and 10, but I'd be scrolling down a lot. So remember, we haven't done this in a while. You can set your table differently. So above window is table set. So if I hit second window and I put the independent, or like I like to say independent because there's no vowels in that, your independent variable, remember, is your x. Your dependent is your y. So right now, my independent's on auto because it's going, it's just going in order 0, 1, 2, 3, 4, 5, etc. But I can put it on ask. So all I did there was I right arrowed over, and then if I hit enter, it'll blink on ask. So that means it's going to ask. So now if I go back to a table, so I hit second graph, now my table is blank. You're like, well, that didn't do me any good. Well, sure it did, because I just need to put these x values in for x in that table. So I'm going to hit 0, enter, 5, 10, 15, 20, and 25. So again, look, the square roots of your perfect squares, your 0 and 25, those are the ones that have your nice numbers. But these other ones, I always do that, draw on my calculator. These other ones in between, I have to kind of graph as best I can, right? So let's see, we have 5. I'm just going to round these to the nearest tenth. So 25.3. This will technically be 31.0 because if you have 30.984, that 8 would make your 9 into a 0. So that's 31.0 and then 35.8. So I'm going to graph these as best I can. So 5 and 17.9, 10, and like a little bit over 25, 15, 31-ish, and 20 is 35.8. So what ends up happening if I connect all these is it looks like this. And you will find that all square root functions look basically like this. So remember, right, I'm just going to grab another piece of paper real quick, that we have ways to tell what functions are just by their graphs. So we have linear, quadratic, exponential, and now we're putting the square root into the mix here. So our linear functions, remember that's just your line at y equals x. Quadratic functions are parabolas. Exponential functions start off really slow and then go shoom like that. And then, and if you're in 6 hour, that reminds you of the domain. We're like, so when we made all of our sound effects. Anyway, sorry, I just had a nice memory there. And then square root functions start at 0, 0 and kind of go like that. So they sort of level off like this, or they appear to level off like this in the same way that exponentials kind of level off. So there you go. So that's what your square root function looks like. Okay. So given the function y equals square root of x plus 1, fill in the table to find out where the object would be at the given x values and graph the function. So I do want to do this in your table because this will create some kind of interesting things here. So if I hit y equals, clear out 8 rad x and just put the square root, so second x squared, sorry about the glare, of x plus 1, and make sure that whatever, like when you're graphing, whatever's under the radical in the equation has to be under the radical up here. Like the square root of x plus 1 is not the same as the square root of x and then plus 1 outside of it, okay? So I'm going to hit second table again, and these are not the same values, right, for x. So I want to fill in the values of x that I have here. So I'm going to fill in -4, -2, 0, 2, 4, 6. And what I want you to notice is that -4 and -2, you're getting errors for y. And I want you to kind of think about why that might be. So if I were to plug in this like by hand, right? So y equals the square root of -4 plus 1. So that's y equals the square root of -3. Well, do you remember what happened when we tried to take the square root of a negative number? It's none, right? It doesn't exist as a real number because there's nothing that you can multiply by itself, which is what you do when you square things, to get a negative number. So, like, just take a look. So if you have the square root of 9, right? Well, let's not do square root, sorry. So if you just have the regular 9, you can get there by 3 times 3 or -3 times -3. In order to get -9, one of these would have to be negative, but then you're not multiplying the same thing together, right? So you're like, to multiply -3 and +3 together is not like squaring 3 or -3, right? Because it has to be the exact same. So that's why anytime you have a negative number, it's narn. So when you get an error in the calculator, error kind of means narn, like the same thing, right? So you get an error also at -2, because if you did -2 plus 1, you still have the square root of -1. So again, be taking the square root of a negative number. At 0, you get 1. at 2 rounded to the nearest tenth, you get 1.7. And then you get 2.3 and 2.6. So going to graph at -4, -2. Like, I'm not going to put anything there. I can't graph -4 error. That's not a coordinate point, right? So what that means is I just start at the first place that I have a number. So I have 0, and that's at 1. And then 2 is at like 1.7. 4 is at 2.3. 6 is at 2.6. That's a little bit off. Sorry. There actually is, like if you put in, this would start at -1. Because if you put in like y equals the square root of -1, so if you put -1 for x plus 1, then you get 0. So that's where your thing would start. And that kind of brings me to this next concept of the domain of a square root function. This we're not going to do because we talked about that. Basically, I was looking for you to say, like, we got an error. Why is that? Well, you can't take square root of a negative number. Okay. So domain, remember, are all possible x values of a graph. So what that means is all possible x values where there's a y value. So all possible x values where a function would exist, right? And like I said on this right here, you can't graph like -4 error. So that -4 not be in the domain of that. Remember that domain, if we were to do that, we kind of did the lines, right? Here's where it starts, and then it kind of goes on forever. So to find the domain of a square root function, you have to find out where you would make your what was under the radical sign greater than or equal to 0. Because again, if what's under the radical is a negative number, you're going to get an error. So the way you do this is actually super easy. You take the what's under the radical and you write it as an inequality in which it's greater than or equal to 0. And you solve the inequality, and that will be your domain. So I have number 1 is y equals 1 plus square root of x minus 4. Okay, I don't care about y, I don't care about equals, I don't care about 1, I don't care about plus, I really don't even care about the radical, I care about only x minus 4. So I say, okay, where is this expression x minus 4 greater than or equal to 0? Because again, I need it to be greater than or equal to 0 in order for me to be able to take the square root of it. So I just solve for x, right? So if I have x minus 4 is greater than or equal to 0, I add 4 to both sides. It's like a one-step inequality. You guys are totally good at this. And I have x is greater than or equal to 4. So that means for all values greater than 4, so for all values greater than 4, sorry about my dog, then that's where that domain will exist. So if you have this as a square root function, it won't start until 4, and then it'll go from there. Okay. Now, number 2, I have y equals the square root of 4 times x plus 3. So again, I'm highlighting this, make it a little easier. The only thing I care about is where that expression right there is greater than or equal to 0. So I take 4 times x plus 3, and I set it up greater than or equal to 0, and then I solve. So these two are multiplying. I could distribute here if I want to, but that will make it more steps instead. Because this whole quantity is multiplying by this whole quantity, I'm just going to divide by 4. So it goes away there. Now I have x plus 3 is greater than or equal to, of course, 0 divided by 4 is 0. My dog will stop barking soon. She is currently being taken outside, so my apologies. And then my last step here, to get x by itself, I would subtract 3. I get x is greater than or equal to -3. So that is my domain. So my domain is all numbers greater than or equal to -3. All right, last one. Y equals 2x minus 1. Sorry. I'm sorry, square root of 2x minus 1. And so I just take 2x minus 1 greater than or equal to 0. Here I would add 1 to both sides. I get 2x is greater than or equal to 1. And then divide by 2. So I get x is greater than or equal to 1/2. So my domain is all values of x greater than or equal to 1/2. So that's pretty easy in terms of domain. All right, your homework. So your optional homework assignment is 11.5 practice B. And number 1 and 2, you're just like putting in, you're just substituting values, right? So number 1, an apartment manager needs to order wallpaper border for the remodel of bathrooms. The function y equals 640 times the square root of x gives the amount of border needed in feet if x is the square footage of each bathroom. Find the amount of border needed if each bathroom is 100 square feet. Okay, there's so much information here that you don't need. Like all of this. We actually don't care that it's like, you know, wallpaper and stuff. I need this and I need that. So all this is telling me to do, like, because it says, you know, x is the square footage and the square footage is 100 feet squared. So y equals 640 times the square root of 100. So instead of x, again, plug in for 100. So y equals 640 times the square root of 100. Square root of 100 is 10. So multiply anything by 10, you just add a 0 to the end here. So y equals 6,400, and that's feet. Okay, that's how you do that one. Number 2 is pretty much the same. Domain of each square root function, that's what we just did. So remember, take what's underneath the radical and set it up greater than or equal to 0. Solve for x. There you go. And then this one is just the tables and graphing that we did. You can just do these right in your calculator. So again, put in the, you know, the y equals whatever it is. So in this one, it's the square root of 4x. And then if you want, again, to just keep your, sorry, gosh, I forget that glares there. To keep your calculator, your table set into ask, then it'll be easier. So the x values here, you just put those in. So you have 0, and then, sorry, I don't know why that did not work. 0, and then 1/4, and then 1, and 4, and 9. And then you don't need this 6. If you want to delete it, you can. So you would just put those in. So you get 0, 1, 2, 4, 6, and then just graph. So 0, 0. 1/4 and 1 is kind of difficult to graph. You can try if you want. 1 is at 2. 4 is at 4. And then 9 is at 6. And again, you can see like this grows pretty quick here and then kind of seems like it's going to level off at some point. All right, so there you go. That is the first lesson for the last week of school. So we will be back tomorrow to try to do another one. So the next one is simplifying radicals, and I would maybe try to memorize some perfect squares before that. All right, have a good day.